Today's lesson is going to focus on applications of scale drawings. In our last lesson, we learned that a scale drawing is proportional to an actual sketch or object. Okay, we learned how to find the scale factor, and then that allowed us to figure out what the relationship is between the scale drawing and the original object. In today's lesson, one of our focuses is going to be how to find an actual distance based off of a scale ratio. Okay, a blueprint is an example of a scale drawing. To find an actual distance from a scale drawing, you will set up a proportion using the measures given. In our first example, they want us to find the actual length of a room if the length on the blueprint is 5.5 inches. The scale given by the blueprint says that a half an inch is equal to 2 feet. Okay, this is called a scale ratio. It is not a scale factor. Okay, one reason why it's not a scale factor is because the scale factor doesn't actually include units. Okay, the reason why it's called a scale ratio is because these units are different from each other. Okay, when the units are different, we call that a scale ratio. Our process, though, for finding the actual length of this room is going to be similar to what we've done in the past. Remember that when we set up our ratios for scale drawings, that we always do the scale length over the actual length. Scale over actual. In this example, the scale length is being measured in inches, and the actual length is being measured in feet. Okay, so what we're going to do is set up our first ratio based on the scale ratio. They tell us that a half an inch corresponds to 2 feet in real life. Okay, so this is our first ratio. And we're going to set it equal to another ratio where we can find the actual length of the room. They told us on the blueprint that the length of the room is 5.5 inches. So I'm going to record that in the numerator, 5.5 inches. We don't know how many feet that is, but we can figure out what it is by figuring out how we scale from a half an inch up to 5.5 inches. In order to figure out how we scaled here, I'm going to take the 5.5 inches and divide it by the half inch. When you do that division, you should get a value of 11, which means to go from a half inch to 5.5 inches, you multiplied by 11. We'll do the same thing down here with our number of feet then. We'll do 2 feet times 11, and that's going to give us a distance of 22 feet. So we can say that the length of the room is 22 feet. Okay, so very similar to the work that we've done earlier in our unit. We set up our rates, in this case inches to feet because it's scale over actual. We set up our given ratio, and then we can scale ahead in order to answer our problem. Our second question says that we need to find the actual width of the room if the width on the blueprint is 3 inches. Same blueprint, so we're using the same exact scale. So remember, we do the scale length over the actual length. And in terms of units, the scale is being measured in inches. The actual distance is in feet. And once again, a half an inch corresponds to 2 feet. A half an inch corresponds to 2 feet. Set that equal to another ratio. On the blueprint, the width is 3 inches. We don't know the number of feet, but we can figure out how we scale in order to figure out the answer. If we do 3 divided by a half, that'll tell us how to scale. 3 divided by a half is 6. So if we did a half times 6, that equals 3. Down here, we'll do 2 times 6, which gives us 12. And again, that is your number of feet. So we can say that the width, this time, the width of the room is 12 feet. Okay, so use that scale ratio that they provide you with, scale over actual, set up your rates, and then you can scale ahead in order to answer your question. In our next example, we have another blueprint here. This is a blueprint of a kitchen. And the question asks or tells us that the island on the blueprint is 6 inches long. They want to know what is the actual length of the island in the kitchen. Okay, so we can see here's the kitchen island. It's measuring 6 inches long on the blueprint. We want to know what the actual length is going to be. And notice down here in the corner is the scale ratio. They tell us that 1 inch on the blueprint is going to correspond to 1.5 feet in actual distance. So let's set up our ratios. Again, remember, it's scale length over the actual length. And this time when we look, they're measuring in inches and feet. All right, so just kind of like what we were doing up above. The scale is being measured in inches. The actual measurement is in feet. And the scale says that 1 inch corresponds to 1.5 feet of actual distance. Set that equal to another ratio. And we know that on the blueprint, the island is 6 inches long. So we'll put that in the numerator, 6 inches. In order to scale from 1 inch to 6 inches, all you had to do was multiply by 6. So we'll do the same thing down here to our number of feet, 1.5 times 6, and that would give us a value of 9. 9 is the number of feet, so we can say that the length of the island, is 9 feet. Underneath that, they want to know what's the actual width of the island. Again, if the width on the drawing is 2.5 inches. Okay, so if they measured this width right here with the ruler, it would be 2.5 inches. How much is that in actual distance? Again, it's scale length over the actual length. And we're measuring the scale in inches, the actual in feet. The scale ratio right here, again, says that 1 inch corresponds to 1.5 feet. Set that equal to another ratio. This time we know that the width on the drawing is 2.5 inches, so that'll go in the numerator. To scale from 1 to 2.5, just multiply by 2.5. Do the same thing in your denominator. 1.5 times 2.5, and we get 3.75, which is the number of feet for the actual width. The width of the island. The width of the island is 3.75 feet, 3 3/4 feet. In our next example, we're going to use scale factors to solve area problems. And in question 5, it says, what is the area in square yards of the deck represented by the scale drawing? So here's our picture. We can see the deck. They've got their umbrella and their lawn furniture there. And more importantly, we can see the scale ratio right here. It says that 1 centimeter on the scale drawing represents 2 yards in actual distance. We can also see the measurements here. Okay, it's 8 centimeters from this corner to this corner, and it's 16 centimeters from this corner to this corner. They want to know what is the area in square yards. Okay, well, right now the measurements are in centimeters. We need to convert these into yards first before we can figure out what the area is going to be. So remember, when we set up our ratios, it's always the scale over the actual distance. The scale this time is being measured in centimeters and yards. So let's set this up as centimeters over yards. And they tell us that 1 centimeter corresponds to 2 yards. And let's start with this section right here. We know that it's 8 centimeters from corner to corner here. 8 will go up in the numerator. To scale from 1 centimeter to 8 centimeters, you simply multiply by 8. Do the same thing to our yards now. 2 times 8 is 16. So this 8 centimeter segment in real life is 16 yards. We need to do the same thing with this segment, the 16 centimeter segment. So again, it's centimeters over yards. The scale says 1 centimeter corresponds to 2 yards. Set that equal to another ratio, 16 centimeters. That'll go up in the numerator. And now to scale from 1 to 16, we multiply by 16. Do the same thing in the denominator. 2 times 16 gives us 32. So this 16 centimeter segment on the scale drawing represents a 32 yard segment in real life. Now that we have the actual measurements in yards, we can calculate the area. The deck is in the shape of a rectangle. To find the area of a rectangle, you simply do base times height. Okay, well, the base is measuring 32 yards. The height is measuring 16 yards. 32 times 16. And when you multiply 32 by 16, you get 512. Okay, so this means that the area of the deck, the area of the deck is 512 square yards. Okay, you could write it 512 square yards like that as well. In the next example, we want to reproduce a scale drawing at a different scale. Students are recreating the landscape drawing shown at the right for a mural. They want the length of the drawing on the mural to be 80 inches. What will be the new scale and the new height of the drawing on the mural? Okay, so if we take a look at our mural right now, we can see that it measures 10 inches long and 8 inches high. The current scale says that 1 inch corresponds to 4 feet. Okay, they want the length of the mural to be 80 inches. So they would like for this to be 80 inches when they do the mural on the wall. They want to know what's the new scale have to be to make that happen and then to calculate the new height. All right, well, before we can come up with the new scale, what we're going to have to do is for this current mural, figure out what are the actual measurements. Okay, it's 10 inches by 8 inches right now. Let's figure out what the actual measurements are. So the way that we set this up, it's inches over feet, the scale over the actual. All right, the scale says that 1 inch corresponds to 4 feet. Okay, let's do the length first. Right now, the length is 10 inches. To scale from 1 inch to 10 inches, just multiply by 10. 4 times 10 to give us the number of feet is 40. So this segment right here, where it's 10 inches, is right now a 40-foot segment. We need to do the same thing with the height. So again, 1 inch corresponds to 4 feet. The height is 8 inches. To go from 1 inch to 8 inches, you multiply by 8. Do the same thing in your denominator. 4 times 8 gives us 32. Again, that's the number of feet. So this is a 32-foot high segment right here in real life. Okay, so currently the drawing is 10 inches by 8 inches. When they make the mural, they want this distance down here to be 80 inches long. In real life, this is 40 feet. So we have to come up with our new scale. All right, so underneath of this, we're doing inches over feet. That's how we've set up our scale. And we know that we want it to be 80 inches long. 80 inches long. Well, in real life, we know that this measurement is 40 feet. So that's the number of feet. And what we want to do is now come up with what the new scale has to be in order to make this happen on the mural. On the mural, we need to know how much is every inch going to represent. So to scale from 80 inches down to 1 inch, you simply divide by 80. Do the same thing in your denominator, 40 divided by 80. And when you do that, you should get a half or 5/10. All right, half of a foot. So the scale for the mural, if we want the length to be 80 inches, the scale that we're going to have to use is 1 inch equals 5/10 of a foot. All right, 1 inch equals 5/10 of a foot. This is the new scale of the mural. Okay, so using this scale, once again, inches over feet, if 1 inch corresponds to a half of a foot, all right, and we know that the actual up here we said was 64, excuse me, we said it was 32 inches, 32 feet rather. It's 32 feet long in height right here. Well, we have to figure how to scale from a half of a foot up to 32 feet. Okay, do a quick division. 32 divided by a half, that'll tell you how to scale. You should get an answer of 64. So 5/10 times 64 gets us to 32, meaning that we need to do 1 times 64 to get our new measurement on the mural. 1 times 64 is 64. So this now is going to represent the height of the mural. All right, the height of the mural is 64 inches. Okay, it started out with an 8-inch height. We figured out that that was a 32-foot height in real life. Then using our new scale, we figured out that since 1 inch corresponds to a half a foot, since it's really 32 feet in real life, all right, that's going to be a 64-inch height on our new mural. The height of the mural is 64 inches. In example 7, we're once again going to reproduce a scale drawing at a different scale. It says that the scale drawing shown represents an existing barn. The shortest side of the barn measures 150 meters. If a new barn that is 2/3 its size replaces the existing barn, what will be the scale of this drawing to the new barn? Okay, so here's our picture right now, the scale drawing. We have our barn. It's 20 inches long here, 10 inches long here. Okay, and the information about the actual barn right now, they said that the shortest side of the barn is 150 meters. Well, the shortest side is found right here on our barn. Right now, 10 inches corresponds to 150 meters. Okay, that's what we have right now. We have 10 inches representing 150 meters. Now, a new barn that's 2/3 the size is going to replace this barn. Okay, so this segment now is no longer going to be 150 meters. We have to figure out what 2/3 of 150 is. So let's start by doing 2/3 times 150 in order to figure out what the actual distance of the new barn is going to be here. Well, 2/3 times 150 over 1, I can simplify with 3 and 150. Their common factor is 3. 3 goes into itself once and into 150 50 times. So we have 2 over 1 times 50 over 1, which is going to be 100. Okay, so the new barn, this distance right here is going to represent not 150 meters anymore, but now it's going to represent 100 meters. Okay, so we have to figure out if this 10-inch segment represents 100 meters, then what is the scale of this drawing to the new barn? Well, again, we always set it up the same way, the scale length over the actual length. The scale length is being measured in inches. The actual length is being measured in meters. All right. We can tell by looking at the picture that the segment is 10 inches long. And we just calculated that this new side on the new barn is going to be 100 meters. We need to figure out what the scale is going to be for this drawing. So we need to know for every inch, how many meters is that going to represent? So we have to figure out for 1 inch, how many meters. To scale from 10 inches to 1 inch, simply divide by 10. Do the same thing in your denominator now, 100 divided by 10, and you will get 10, which is the number of meters. Okay, so the scale is going to say that 1 inch equals 10 meters. This is the scale for our new barn. Okay, if we change this from 150 meters to 100 meters, 10 inches corresponds to 100 meters, which means that every inch corresponds to 10 meters.